morning, students. In the previous lecture, we have discussed how to solve the quadratic equations by use of general formula. There are 4 more questions related to that topic. Exercise 5, question number 6, 7, 8, 9. Question number 6, 7, 8, and 9. You have to solve these 4 questions, solution of quadratic equation, or solve the quadratic equation in the question number 6, 7, 8, 9 in your self practice. આ 4 question self practice માં કરવાના છે, બરાબર છે? ચલો હવે જોઈએ exercise 5, question number 5. Convert the following in polar form. Polar form માં આપણે કન્વર્ટ કરવાનું છે. The first question is given z equals to 1 plus 7i divided by 2 minus I whole square. First of all, check that the complex number is in standard form or not. So here the complex number is not in standard form. First of all, we have to convert this complex number in standard form. For that we have to simplify the denominator first, because whole square is given here. A minus b whole square, that means a square minus 2ab means 2 into 2 4i 2ab plus b square means I square. Simplify this. I square equals to minus 1, therefore z equals to 1 plus 7i divided by 4 minus 1. I am writing directly 3 minus 4i. Clear? 4 minus 1, which is equals to 3 minus 4i. Now we have to take the conjugate of denominator. Multiply and divide by conjugate of denominator 3 minus 4i. The conjugate of 3 minus 4i is 3 plus 4i. Therefore, I am multiplying and dividing by 3 plus 4i. Now, multiply the numerator as well as denominator. So, 1 into 3, 1 into 4 plus 4i. 7 into 3, 21 plus 21, 7 4s are 28 into I square. Divide by a minus b into a plus b. So a plus b into a minus b is a square minus b square. A square means b square 9 minus b square 4 square 16 into I square. 16 into I square. Simplify this thing. We are getting z equals to 3 plus 4i plus 21i. This is 25i minus 20 minus 28. Minus 28. I am writing directly 3 minus 20. जो डायरेक्ट ना लखो है ना खबर पड़े तो रेवा दो. डायरेक्ट ना लखो. चलो આપણે डायरेक्ट નથી લખતા. 3 plus 25i, 3 plus 25i minus 28 divide by 9 and minus I square equals to minus 1. Minus 16 into minus 1, which is equals to plus 16. Therefore, we are getting z equals to 3 minus 28 minus 25 plus 25 I divide by 25 minus 25 plus 25 I divide by 25. Now divide 25 separately. We are getting, if we are dividing 25 separately, then we are getting z equals to minus 1 plus I. We are getting minus 1 plus I. Z equals to minus 1 plus I. Now the question is in standard form, then we can convert it in polar form. So for converting it in polar form, compare it, first of all, compare it with z equals to a plus ib. Z equals to a plus ib. Therefore a equals to -1, b equals to +1 here. Now find the modulus of z. Modulus of z r equals to, which is equals to r, formula is under root a square plus b square. Therefore r equals to under root -1 square plus 1 and b square plus 1, which is equals to under root of 2. R equals to root 2. Now find the value of cos theta and sin theta. Cos theta equals to a by r and sin theta equals to b by r. Put the value of a, b and r. We are getting cos theta equals to -1 by root 2, which is negative, and sin theta, which is equals to +1 by root 2, which is positive. Cos theta is negative, sin theta is positive. Therefore the quadrant is second quadrant. In the second quadrant we can write theta equals to pi minus alpha, where alpha equals to pi by 4. Alpha કેટલો થશે? cos theta 1 by root 2, that means pi by 4. Therefore argument of z, which is equals to theta, is written as pi minus alpha. Alpha is pi by 4. Therefore I am getting theta equals to 3 pi by 4. 3 pi by 4. 4 minus pi means 4 pi minus pi. 3 pi by 4 is your argument of z, theta. The polar form. Now the polar form of z is given by z equals to r cos theta plus I into sin theta. So put the value of r and theta. We are getting z equals to r is root 2 cos 3 pi by 4 plus I sin 3 pi by 4. Z equals to root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. This is the polar form of the question. 1 plus 7i divided by 2 minus I whole square. Now we are going to discuss the second question. The second question is z equals to 1 plus 3i divided by 1 minus 2i. 1 plus 3i divided by 1 minus 2i. This is also a simple question. First of all, see that the complex number is in standard form or not. So the complex number is not in standard form. First of all, we have to convert this complex number in standard form by taking the conjugates of denominator, then multiply by its conjugate. And a conjugate से multiply divide करना पड़ता है. Therefore, z equals to 1 plus 3i divided by 1 minus 2i into 1 plus 2i is the conjugate 1 plus 2i. Clear? Now simplify numerator and denominator. 1 ones are 1 plus 2i plus 3i plus 3 twos are 6i square divided by a plus b, a minus b, 1 square 1 minus 4i square, a square minus b square. Z equals to 1 plus 5i minus 6, i square minus 1 means minus 6 divided by 1 plus 4 minus 1 into 1 minus 1 into minus 1 એટલે plus 4 થઈ જશે. Clear? Z minus minus plus. Z equals to, so that's 1 minus 6 means minus 5 plus 5i divided by 5. Divide separately. We are getting z equals to minus 1 plus I. Z equals to minus 1 plus I. જોઈ લો ભાઈ બંને એવું સેમ ક્વેશ્ચન આવી ગયો. બાકી બધું જ કેલ્ક્યુલેશન સેમ. એટલે તમે જાતે આખું કેલ્ક્યુલેશન લખજો ભાઈઓ. मैं भले लखू छू सेम एज क्वेश्चन 1. બરાબર ક્વેશ્ચન 5 નો 1 સેમ એઝ ક્વેશ્ચન 5 નો 1 બાકી આ કેલ્ક્યુલેશન તમારે આખું જ લખી દેવાનું કેલ્ક્યુલેશન બતાવી દેવાનું બરાબર છે આ કેલ્ક્યુલેશન ખાસ બતાવી દેજો ક્લિયર Now the next question, exercise 5, question number 15. Find the modulus of 1 plus I divided by 1 minus I minus of 1 minus I divided by 1 plus I. कोई भी कॉम्प्लेक्स नंबर નો તમારે મોડ્યુલસ ફાઇન્ડ આઉટ કરવું હોય, આર્ગ્યુમેન્ટ ઓફ z ફાઇન્ડ આઉટ કરવું હોય, કોન્જ્યુગેટ ફાઇન્ડ આઉટ કરવું હોય, પોલાર ફોર્મમાં રિપ્રેઝેન્ટ કરવું હોય, પહેલા એને સ્ટાન્ડર્ડ ફોર્મમાં કન્વર્ટ કરવું પડે. સ્ટાન્ડર્ડ ફોર્મમાં છે ના તો કન્વર્ટ કરવું પડે. પહેલા આપણે એનું નામ આપી દેવાનું છે. તો z ઇક્વલ્સ ટુ 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I. શું કરશો તો તમે LCM ને સિમ્પ્લિફાઈ કરી શકો ને પહેલા LCM લઈને સિમ્પ્લિફાઈ કરો. therefore LCM is z equals to LCM is 1 minus I into 1 plus I. This is your LCM. Multiply this with this. We are getting 1 plus I into 1 plus I is 1 plus I whole square minus 1 minus I whole square. Expand by use of a plus b whole square and a minus b whole square. We are getting a square is plus 1 plus 2ab 2I and plus I square minus this one is 1 minus 2I plus I square divided by a plus b into a minus b is a square minus b square and square minus I square. A square minus b square. Simplify by putting the value of I square equals to minus 1. We are getting 1 plus 2I minus 1 minus 1 minus 2I minus 1 divided by 1 I square minus 1 minus into minus 1 is plus 1. Therefore z equals to 1 1 cancel, answer is 2I minus of minus 2I 1 1 cancel, 1 minus 1 cancel minus 2I divided by plus minus minus plus. Therefore we are getting 2I plus 2I divided by 2. This is equals to 4I divided by 2. Therefore I am getting z equals to 2I. Z equals to 2. આપણે શું ફાઇન્ડ આઉટ કરવાનું છે મોડ્યુલસ. therefore modulus of z denoted as modulus of z, which is also denoted r equals to under root a square plus b square. That means under root of 0 plus 4. Answer is 2. બરાબર અને કમ્પેર કરવાનું કોની જોડે a plus ib સાથે એટલે a ની વેલ્યુ આવશે 0 અને b ની વેલ્યુ આવશે plus 2. તો કમ્પેર કરીને આપણે મોડ્યુલસ ઓબ્ટેન કરી લીધું. બહુ જ ઈઝી ક્વેશ્ચન છે. ક્લિયર? પહેલો ક્વેશ્ચન Now, the next question. The question is question number 14, exercise 5. Find the real numbers x and y if x minus iy into 3 plus 5i is the conjugate of minus 6 minus 24i. Here, the question is x minus iy into 3 plus 5i is equals to the conjugate of this minus 6 minus 24i bar. Conjugate of this. આનો conjugate આ છે. Okay? If this is the conjugate of this. Conjugate માટે આપણે 5 સિમ્બોલ યુઝ કરીએ છીએ. આનો conjugate હવે આપણે લખી દઈએ. therefore આને મલ્ટીપ્લાય કરો 3x 3 into x plus 5x into I minus 3yi and minus 5y I square, which is equals to minus 6 plus 24i. Conjugate, that means we have to change the sign of imaginary part only. Simplify this thing. We are getting 3x plus 5xi minus 3yi. This is I square equals to minus 1 minus into minus 5 plus 5y equals to minus 6 plus 24i. Now real parts ने जोड़े रखो और imaginary parts ने जोड़े रखो. Therefore we are getting 3x plus 5y plus હવે real parts अलग imaginary parts માંથી I common ले लो એટલે શું રહેશે 5x minus 3y which is equals to minus 6 plus 24i. This is in standard form, this is also in standard form. Both are equal complex numbers, therefore we can compare directly real parts as well as imaginary parts. Therefore we are getting 3x plus 5y equals to minus 6 and 5x minus 3y equals to 24. Both equations are here. Now we have to find the value of x and y by solving these two variable pair of two variable linear equations. चलो एक काम करिए y નો એલિમિનેશન કરીએ. चलो y નો એલિમિનેશન કરવું હશે તો આપણે આ ફર્સ્ટ ઇક્વેશન્સ ને 3 થી મલ્ટીપ્લાય કરવું પડશે, સેકન્ડ ઇક્વેશન ને 5 થી મલ્ટીપ્લાય કરવું પડશે. Therefore we are getting 3 3s are 9x plus 5 3s are 15y equals to 6 3s are minus 18, and this one becomes, this will becomes, and this another multiply करशो 5 3 25x minus 5 3s are 15y which is equals to 24 5s are 120. Okay, simplify this thing. Directly add plus 15y minus 15y will get cancelled, plus 15y and minus 15y will get cancelled. Therefore remaining term 9x plus 25x, this will becomes 34x which is equals to 120 minus 80 102 102. Therefore x equals to 102 divided by 34, 102 divided by 34. So cancel करवानो ट्राई करिए. 17 2s are 34 અને 102 17 ના મલ્ટીપલ માં છે કે નહીં જોઈ લેજો, બરાબર છે, અને એનું કેલ્ક્યુલેશન જે બી આન્સર આવે અહીંયા લખી દેજો. ક્લિયર? લગભગ જોઈ લઈએ. 4 3s are 12. I think 34 3s are 1023 હશે. 34 3s are 102. 34 3 3s are 90, 90 and 4 3s are 12. 90 plus 12 102. This is okay. So this will becomes equals to 3. 34 3s are 102. Okay. Now put the value of x in any equation. Put x is equals to 3 in any equation and putting this in this equation. 3x plus 5y equals to minus 6. Therefore 3 3s are 9 plus 5y equals to minus 6. Therefore 5y equals to minus 6 minus 9 minus 15. Therefore y equals to minus 15 by 5. Answer is 3. The value of x is 3 and y is minus 3. X equals to 3 and y equals to minus 3. આપણે આ બંને real numbers obtain કરવાના હતા, બંને real numbers obtain થઈ ગયા. Clear? Now we are going to discuss the next question, example number 12. Example number 12. Find the conjugate of the complex number is given and giving the name z equals to 3 minus 2i into 2 plus 3i whole divided by 1 plus 2i into 2 minus i. This is your complex number. Is this complex number in standard form or not? Here the complex number is not in the standard form. First of all, we have to convert this complex number in standard form a plus ib. Then we can directly write the conjugate of any complex number in standard form. પહેલા તો આને standard form માં કન્વર્ટ કરો. એની માટે numerator as well as denominator ને multiply કરી simplify કરો. Here z equals to 3 2s are 6 plus 3 3s are 9i minus 4i, and this one becomes minus 6i square. Divide by, simplify this thing, 1 2s are 2 minus i plus 4i, and this will becomes minus 2i square. Simplify this thing by putting I square equals to minus 1. 6 9i minus 4i, which is equals to plus 5. This will become plus 6 divided by 2 minus i plus 4i, which is equals to plus 3i, and this will become I square is minus 1 into minus 2 plus 2. Simplify this thing. We are getting 6 plus 6 12 plus 5i, 12 plus 5i divided by 4 plus 3i, divided by 4 plus 3i. Now we have to multiply numerator as well as denominator by the conjugate of 4 plus 3i. The conjugate of 4 plus 3i is 4 minus 3i. આપણે શાનાથી મલ્ટીપ્લાય કરશું? 4 minus 3i. 12 plus 5i divided by 4 plus 3i into 4 minus 3i whole divided by 4 minus 3i. Clear? Simplify numerator as well as denominator. We are getting 12 4s are 48 minus 36i, 5 4s are 20i, and this will become minus 15i square whole divided by a plus b into a minus b. A square means 4 square, 16 minus 3i square means 9i square. Okay, simplify this thing. Z equals to 48 minus 36 plus 20i minus 16i minus plus 15 divided by 16 plus 9. Simplify this thing. Z equals to 48 minus 16i divided by 25. 48 minus 16i divided by 45. Clear? Now simplify by separating, dividing by 25. We are getting Z equals to 48 by 25 minus 16 by 25i. Z equals to 48 by 25 minus 16 by 25i. Clear? This is the simplification. No, sorry. 48 plus 15 is that. 48 plus 15 is that. 8, 3, 4 plus 1, 5 and 6. 63. This will become 63. Okay? 63 by 25 minus 16 by 25. This is the complex number in the standard form. now conjugate of z પહેલા સ્ટાન્ડર્ડ ફોર્મમાં ના આપ્યું હોય તો કન્વર્ટ કરવું જ પડે અને પછી conjugate of z ને ડિનોટ કરવું હોય તો z બાર equals to 63/25 ખાલી ઇમેજનરી પાર્ટની શું ચેન્જ કરવાની સાઇન ચેન્જ કરવાની એટલે કે માઈનસ નું શું થઈ જશે પ્લસ z બાર equals to 63/25 plus 16/25 I clear આ થયો તમારો આન્સર બહુ જ સિમ્પલ છે now the next question exercise 5 question number 2 question is very simple for any two complex numbers z1 and z2 prove that real part of z1 into z2 is equals to real part of z1 into real part of z2 minus imaginary part of z1 into imaginary part of z. આ ટાઈપનો ક્વેશ્ચન સોલ્વ કરવો હશે તો z1 અને z2 બે કોમ્પ્લેક્સ નંબર્સ આપણે સપોઝ કરવા પડશે. લેટ I am taking z1 equals to a1 plus ib1. z1 equals to a1 plus ib1. What is the real part of z1? Real part of z1 is a1 and imaginary part of z1 is b1. Same way, second number z2 is equals to a2 plus ib2. Therefore, the real part of z2 is a2 and imaginary part of z2 is b2. Okay? ચલો આ બધા જ પાર્ટ્સ આપણને મળી ગયા. હવે વાત કરીએ રિયલ પાર્ટ ઓફ z1 z2. For obtaining the real part of z1 z2, first of all we have to obtain z1 into z. Value of z1 is a1 plus ib1. z2 is a2 plus ib2. Simplify this multiplication. We are getting a1 into a2 plus a1 into b2 I into b2i plus a2 into b1i a2 into b1i and plus b1 b2 I square b1 b2 I square. So I square is equals to minus 1. We know that. So a1 a2 plus a1 b2 I plus a2 b1 I minus b1 b2 I square equals to minus 1. હવે આમાંથી I વાળી ટર્મ્સ અલગ બાકીની ટર્મ્સ અલગ પછી એને સ્ટાન્ડર્ડ ફોર્મમાં રિપ્રેઝન્ટ કરો a1 a2 minus b1 b2 આ થઈ ગયો વિધાઉટ I અને પ્લસ I વાળી ટર્મ્સમાંથી I કોમન a1 b2 plus a2 b1 I વાળી ટર્મ્સમાંથી શું કોમન I કોમન ક્લિયર થઈ ગયો આ તમારું કેલ્ક્યુલેશન. So this is the z1 z2. Now see here, we want only real part of z1 z2. We want only real part of z1 z2. So what is the real part of z1 z2? The real part of z1 z2 is this a plus ib. So this a is real part. The real part of z1 z2 is a1 a2 minus b1 b2. a1 a2 minus b1 b2. Now what is a1? a1 is real part of z1. Therefore we can write real part of z1 z2 equals to a1 is real part of z1, a2 is real part of z2, real part of z2 minus b1 is imaginary part of z1, imaginary part of z1 and b2 is imaginary part of z2, imaginary part of z2. Okay, hence true. See, real part of z1 z2 equals to real part of z1 into real part of z2 minus imaginary part of z1 into imaginary part of z2. Hence proved. જે આપણે પ્રૂવ કરવાનું થાય. ઓકે, એટલે સુધી રાખીએ આજના વિડિયોને એક લાઈક કમેન્ટ જરૂર આપો અને થેન્ક યુ વેરી મચ. ક્લિયર?